Okay, today we're going to discuss the application integrals. To start, we have to find the area under a curve. So definite integrals have many applications. We can use definite integrals to find the area of the region bounded by a curve, the volume created by rotating a curve, the length of a curve, the mean value of a function, the center of mass of an object, and to calculate the displacement and work done in motion and projectile problems. So most of these applications are useful in mathematics or physics. So in this chapter, we will of the definite integrals of the definite integral in mathematics. So the first topic here we have finding the area. So we let f as the absolute value AB yields to R be a continuous function such that okay, let the interval yields to R be a continuous function such that for every x, f of x is greater than or equal to 0. Then the area of the region between y equals f of x and the x-axis on the interval AB is the area is equal to the integral of f of x dx evaluated from A to B. So the theorems above gives us four important results. So number one, if f of x is less than or equal to 0, then the area of the region between y equals f of x and the x-axis on the interval AB will be area is equal to the integral of the negative f of x dx evaluated from A to B or equals the negative of the integral of f of x dx evaluated from A to B. So what we did here with the negative sign, we put that one outside the integral sign. So more generally, if y equals f of x is any continuous function in the interval AB, then the area between y equals f of x and the x-axis is area is A is equal to the integral of the absolute value of f of x dx evaluated from A to B. So the illustration now of this conclusion number one. So since there is a negative sign there, then the graph for now will be below the x-axis. So in number two, in the figure, the total area of the region will be area is equal to A plus B plus C is equal to the integral of f of x dx evaluated from A to B minus, it's minus because the area of B here in the graph is below the x-axis. So minus the integral of f of x dx evaluated from B to C. Okay, that's B to C plus the next area there is the C. We have the integral of f of x dx evaluated from C to D. We have to remember that the definite integral of f of x on the closed interval AB is the integral of f of x dx evaluated from A to B is equal to A minus B. So this is now the illustration for that, for letter A. And letter B here, we have the area between f of x and the x-axis on the closed interval AB. So the area now will be equal to A plus B. Conclusion number three. So we have the area between y equals f of x, the y-axis, and the lines y equals m and y equals n is a is equal to the integral of f of y dy evaluated from m to n. So if we're talking about y, the y-axis, then the graph will look like this. So number four, we can use the formula for the area under a curve to define the area between two curves. So we have here, so there are three figures illustrated in this conclusion under the formula for the area under a curve to define the area between two curves. So the red one here is the g of x, and the graph now for the f of x is the blue one. So the shaded part there is the area of between the two functions. So and including also the second term, so the second figure as well as on the third term. So we let f of x and g of x be the two curves. Then the area A between f of x and g of x on the interval AB. So the formula now here, we let A is the area, is equal to the integral of f of x minus g of x. So the difference of the two functions of d of x is evaluated from A to B. So the intervals there is small letter A and the small letter B. Okay? So for letter B, we have 4B, we have the area between f of x and g of x is, based on this figure, we have a plus b plus c, the sum of the areas in this figure, will be equal to the integral of f of x minus g of x of dx. So it the red one there is the f of x minus the lower graph is the g of x. So that's why we have f of x minus g of x evaluated from A to B. And the second term here now, so the the line above is the blue one that is for g of x. That is why we have here g of x minus the graph here below that line is the red one. That's why we have f of x. So therefore, we have here now g of x minus f of x dx evaluated from B to C. Now, on the third one, we have the upper graph now is the f of x, and the lower graph is for g of x. That's why we have f of x minus g of x dx. So in other words, so upper graph minus the lower graph. So be careful on analyzing the graph. In addition to that, we also have here the area of the plane region bounded by x equals a, x equals b, y equals g of x, and y is equal to f of x is given by the formula of the uppercase of a is designated for the area is equal to the integral of f minus g of x dx evaluated from a to b. So that's almost similar to the one that I have presented. So this is now the graph for that. Now let's try to use these formulas or concepts to solve for the problem. For number one, we have find the area A of the region bounded by the graph of y equals x plus 1, the x-axis, and the lines x equals 2 and x equals 4. So the lines here, x equals 2 and x equals 4, it refers to our limits or the boundaries as A and B. And the shaded portion here is the area of this bounded by the graph. We have the equation of y equals x plus 1. Now, to find the area of that, so we have here, write the formula of A is equal to the integral of f of x dx evaluated from A to B. So that one now will be equal to A is equal to the integral of the meaning of f of x. Now we have x plus 1 of dx. The value of A now equals 2 and the value of B now equals 4. So this is now our working equation. So let us now find the integration for that. So very simple. They're just somewhat like doing the integration for basic integration. So we have here now the integration for this. We have x squared over 2 plus x, and this will be evaluated from 2 to 4. So take note this now for the area. So we have now to evaluate using the FTC, the fundamental theorem of calculus. So we have now 4 squared over 2 plus 4. That is your 4 f of b minus f of a. We have now minus, we have 2 squared over 2 plus 2 and close. Then simplify. 4 squared is 16 divided by 2. We have 8. So 8 plus 4, we have now 12. Minus 2 squared over 2. We have 4 divided by 2 is 2. Plus 2, we have 4. So we have 12 minus 4 is equal to 8. So that is now the area of this problem. Number 2, find the area A bounded by the graph of y equals negative 3x plus 1, the x-axis, and the lines x equals 1 and x equals 3. If we are going to graph this equation, so the line y equals negative 3x plus 1 will be below the x-axis. So since it is below the x-axis, so the formula now that we're going to use is a is equal to the integral of the negative of f of x dx evaluated from a to b. So by substitution, the integral of the negative of the value of f of x, now we have the negative 3x plus 1 of dx to the value of a is 1, the value of b is 3. So simplifying first the integrand by using the distributive property, so the integral now of 3x minus 1 of dx evaluated from 1 to 3. So by integration for that now, we have 3x squared over 2 minus x, and this will be evaluated from 1 to 3. So therefore, if we're going to evaluate now using the fundamental theorem of calculus, so we can write now as 3 over 2 times 3 squared minus 3 minus the lower limit, we have 3 halves times 1 squared minus 1. So this will give us now, we have, simplifying this one, 3 squared is 9 times 3 halves. We have now 27 over 2 minus 3 minus, we have 1 squared is 1 times 3 halves. So we have 3 halves minus 1. So simplifying that will give us now 21 over 2 minus 1 half. So therefore, the area now will give us the value of 10. Okay, for number 3, what the question is, what is the area of the finite region of y equals 1 minus x squared and the x-axis? So in this problem, the intervals or the limits is not given. So therefore, we're going to find first the limits. So to solve for that, we're going to write here as f of x. F of x stands for y. So f of x equals 1 minus x squared. I write, okay, from the given equation of y equals 1 minus x squared, so I just write it first in terms of f of x because we know that y is equal to f of x. So therefore now we have f of x equals 1 minus x squared, and you let this one be equal to 0. So that if that is now equal to 0, so I can write now 0 is equal to 1 minus x squared, then solve for x. So by transposing, this can be positive x squared is equal to 1, and take the square root of that. So therefore, x now is equal to positive and negative 1. So this one will give us now our boundaries or the limits, which is the negative 1 to positive 1. So by writing now the formula for finding the area, we have area now is equal to f of x dx evaluated from a to b. So therefore, we have f of x is 1 minus x squared of dx, and the limits now is from negative 1 to positive 1. Then take the integration for that. So the integration of 1 dx is just x minus x cubed over 3. And then this will be evaluated from negative 1 to positive 1. Now the continuation will be here. So we have 1 minus 1 cubed over 3 minus negative 1 minus negative 1 cubed over 3. So simplifying that one, we have 1 minus 1 cube over 3. That's just equal to 1 cube. So what is now 1 minus 1 cube? We have 2 cube minus, this one now becomes, the cube of negative 1 is negative 1. So therefore, negative 1/3 times negative 1. So I will write it first, negative 1. So the negative of negative becomes now positive 1/3. So simplifying it again. So we have 2/3 minus negative 1 plus 1/3. That is now, we have negative 2/3. So by simplifying further, we have 2/3 minus negative 2/3. So the answer now will be 4/3. Okay, number 4. What is the area of the finite region between the graph of y equals 2 minus 3x plus x squared and the x-axis? Since the value of the limits is not given, then we are going to solve that by equating the equations to 0. So I can write now as, we have 0 is equal to 2 minus 3x plus x squared. So to solve for the value of x, so I would choose the quadratic formula. So we have x is equal to the negative b plus and minus the square root of b squared minus 4ac all over 2a. So x now equals the negative of b, which is the negative of negative 3, plus your b now is the negative 3 squared minus 4 times your a is the coefficient of x squared, which is now 1, times the value of c is the constant, which is now 2, all over 2 times the value of a is 1. So simplifying that one, that's negative of negative 3 is positive 3, plus and minus the square root of, this is now the square of negative 3 is 9, minus 4 times 1 times 2, we have now 8 all over 2. So simplifying further, we have 3 plus and minus. The square root of 9 minus 8 is 1. The square root of 1 is 1 all over 2. So x sub 1 now will be 3 plus 1 is 4. 4 divided by 2 is 2. Now for x sub 2, we have 3 minus 1 is 2, and 2 divided by 2 is 1. Therefore, the values now of our boundaries is 1 and 2. So after knowing the value of x's or the value of the limits, so we are now going to write the formula. But before that, let us analyze first the graph. So since the graph, we have here a portion of that area now, and that area rather is below the x-axis. So since the area of the graph that is below the x-axis will give us the formula of the negative of, so we have the formula there, it will be equal to a is equal to the negative of f of x dx evaluated from a to b. So because of this, the area is below the x-axis. That is why we have the negative of f of x in the integrand. So solving for that now, we have the integral of the negative of 2 minus 3x plus x squared of dx evaluated from 1 to 2. So simplifying first the integrand, we have the negative of 2 plus 3x minus x squared of dx evaluated from 1 to 2. So the integration for the first term, we have the negative 2x. Integration of the second term, we have positive 3x squared over 2 minus the next one now is x, the power of 3 over 3, and then evaluated from 1 to 2. So by using the fundamental theorem of calculus, okay, so negative 2 times 2, we have negative 4 plus 3 times 2 squared. So 2 squared is 4 times 3 is 12 divided by 2. We have now 6 minus 2 cubed is 8 divided by 3. So we have 8 over 3. So minus the lower limit now, we have negative 2 times 1 is negative 2. And then 1 squared is 1 times 3 halves. We have plus 3 halves minus 1 cubed over 3 is just 1 cube. So simplifying that one, so that will just give us the value of 1 over 6. Okay, for number 5, we have find the area of the region bounded by the graph of y squared minus 1 equals x and the y-axis. So if you have remembered, the first 4 problems we talk about the x-axis. So by this time, we're dealing now with the y-axis. As you can see, the graph now is opening to the right. Since the area of this curve is below the y-axis, then the formula now will give us area is equal to the negative of f of y dy. Take note that it is under the y-axis. That is why I'm using the formula now of area is equal to the integral of the negative of f of y dy because the area is below the y-axis. And that is now evaluated from A to B. Since the limit is not given, then we are going to solve for y. So we have y squared minus 1 is equal to 0. Okay? So solving for y now, we have y squared is equal to 1. Therefore, y is equal to the plus and minus of 1. Okay? So we can now go back in here. So the area now is equal to the negative of y squared minus 1 of dy, and that is evaluated from negative 1 to positive 1. So we have now area is equal to, using distributive property first, we have the negative y squared plus 1 of dy evaluated from negative 1 to positive 1. Now take the integration for that. So I have the negative y cubed over 3 plus y, and then evaluated from negative 1 to 1. So by using the FPC, we have the negative of 1 cubed over 3 plus 1 minus the negative of negative 1 cubed plus negative 1. So simplifying this one, 1 cubed times negative is negative 1/3 plus 1 minus, we have, so the cube of negative 1 is negative 1. So negative 1 over 3 times negative becomes now 1/3, then minus 1. So simplifying that one, so we have now, we have negative 1. The LCD is 3. So we have 3 divided by 3 is 1 times negative 1, negative 1. Then 3 times 1, we have positive 3. And minus, we have here also is 3. So we have 1 minus 3. So simplifying further, we have now negative 1 plus 3 is 2/3 minus 1 minus 3 is negative 2/3, as therefore 2/3 minus negative 2/3, so the answer now is 4 over 3. So the area now is 4 over 3.